This is Bob Capetta from the College of the Florida Keys, and this lesson is on complex numbers. So we know the square root of 9 is 3 times 3. So when we ask that question, we ask ourselves, what number multiplied by itself is 9? And we get 3. So we're going to create this new number called I. And here's how we define I. I times I equals -1, or I squared equals -1. I stands for imaginary. So we put this together, we will say then the square root of -1 equals I. Now negative I times negative I also would equal -1, but the principal square root will be I. So if we're using that, we can do things and ask ourselves questions like, what is the square root of -36? Well, that would be the square root of -1 times the square root of 36, which is I times 6, which is 6I. So the square root of 36 is -36 is not a real number. 6I is a complex number. I is imaginary. 6I is an imaginary number. And we're going to add that to our list of numbers that we have that will enable us to solve some other sorts of problems. So let's just do another one. Square root of -49 is the square root of -1 times the square root of 49, which is I times 49, 49I. Now what if we raise I to various powers? We've already said I squared is -1. Well, how about I cubed? Well, I cubed is I times I times I, or I squared times I, which is -1 times I, which is -I. I to the 4th would be I squared times I squared, which is -1 times -1, which is +1. So that's nice to know that I to the 4th is +1, so if we have 4 i's, we can replace it with 1 to make our life a little simpler. So a standard question that I might ask is something like, what is I to the 10th power? So we know I to the 4th is 1. So what is I to the 10th power? Well, it's I to the 4th, that's 4 of them, which would be 1. I to the 4th again, another 1, and then I need 2 more, which would be I squared. So putting this together, then I to the 4th is 1, I to the 4th is 1, I squared is -1. So I to the 10th, 1 times 1 times -1 is -1. And I could also have something like I to the 43rd power. What would that be? Well, that would be I to the 4th raised to the 10th power. So that's I to the 40. And I need another I to the 3rd power. So I to the 4th is 1 to the 10th power times I to the 3rd power. 1 to the 10th is just 1 times I to the 3rd power. So that's I squared times I squared times I, which is -1 times I, which is, of course, -I. So that's how I deal with powers of I. But now we can also add and subtract complex numbers. Now, I is imaginary. If I put an I together with a real number like 2 plus 3I, we call this a complex number, although 3i is also part of the set of complex numbers. And if I want to add 2 plus 3i plus 5 minus 9i, the process is exactly the same as it was with adding like terms. We add the real parts. 2 plus 5 is 7, and then 3i plus -9i is -6i. So we get 7 plus -6i, or 7 minus 6i. And the process is essentially the same if we're doing subtraction. So if I have complex numbers and I want to subtract them, 1 minus 4i minus -2 plus 8i. We're going to go ahead and rewrite the subtraction as adding the opposite. So this would be 1 minus 4i plus the opposite of -2 plus 8i, which becomes 1 minus 4i plus the opposite of negative 2 is positive 2, plus the opposite of 8i is negative 8i. Now I get 1 plus 2, the real part. 1 plus 2 is 3. Negative 4i plus negative 8i is negative 12i. So we get 3 plus negative 12i, or in somewhat simpler form to write, 3 minus 12i. So adding and subtracting complex numbers is very similar to adding and subtracting binomials by looking for like terms. The process is essentially the same. But how do we handle multiplication of complex numbers? So if I have 4 minus 2i multiplied by negative 3 plus 5i. So we're multiplying this. Remember that I squared equals negative 1. That's important for us to know. So I squared is negative 1. We're going to multiply these together. I like to use my multiplication box to make sense of that. So let's do that. So I have 4 minus 2i down here, and I have negative 3 plus 5i up here. 4 times negative 3 is negative 12. 4 times positive 5i is positive 20i. Negative 2i times 3 is positive 6i. Negative times a negative, of course, is positive. 5i times negative 2i is negative 10i squared, but I squared is negative 1. So that's negative 10 times negative 1, which is positive 10. So if I put all this together, I have negative 12 plus 20i plus 6i plus 10. And you can see, again, we have like terms to manage. The real part, negative 12 plus 10 is negative 2. 20i plus 6i would be 26i. Now, standard form for a complex number, by the way, is a plus bi. So we prefer to write the complex number with the real part plus the imaginary part, a plus bi, to define that. So let's go ahead and do another multiplication problem with complex numbers. Let's take a look at three plus 2i times 6 plus 4i. And let's see how that behaves. Again, we're going to use our multiplication box and see what that looks like. 3 plus 2i, 6 plus 4i. 6 times 3 is 18. 4i times 3 is plus 12i. 6 times plus 2i is another plus 12i. 4i times 2i is 8. I squared is negative 1. That's 8 times negative 1. That's negative 8. So if we put all this together, we have 18 plus 12i plus another 12i plus negative 8. Add the real parts. 18 plus negative 8 is 10. 12i plus 12i is 24i. So my answer to that is 10 plus 24i. And let me go ahead and show you how we square a complex number. So if I have 2 plus 5i quantity squared, that just means 2 plus 5i times 2 plus 5i. So be careful not to try to square each term individually. You need to make sure that you distribute correctly. So if I'm distributing, I want to use my multiplication box, so I'll do that. 2 plus 5i times 2 plus 5i. 2 plus 5i times 2 plus 5i. 2 times 2 is 4. 5i times 2 plus 10i. 5i times 2 plus 10i. 5i times 5i is 25i squared. 25 times negative 1, negative 25. So if I add all these together, we get 4 plus 10i plus another 10i plus negative 25. Add the real parts together first, since our standard form is a plus bi. 4 plus negative 25 is negative 21. 10i plus 10i is 20i. So we've looked at addition of complex numbers, we've looked at subtraction of complex numbers, and we've looked at multiplication of complex numbers. Let's go ahead and take a look at division of complex numbers. So if I have 7 minus 2i divided by 2 plus 3i, how is this going to work? Well, we're going to go ahead and multiply top and bottom by the conjugate. So the top is 7 minus 2i, the bottom is 2 plus 3i, the conjugate of the bottom. We multiply the bottom by the conjugate. The conjugate of 2 plus 3i is 2 minus 3i. Multiply the bottom by 2 minus 3i and the top by 2 minus 3i. If we multiply the same thing on the top and the bottom, we know that we have not changed the value of the fraction. So what will this be? We're going to multiply those. So we need to multiply 7 minus 2i times 2 minus 3i. So let's do that. 7 minus 2i times 2 minus 3i. 7 minus 2i times 2 minus 3i. 7 times 2 is 14. 7 times negative 3i is negative 21i. Negative 2i times 2 is negative 4i. Negative 3i times negative 2i, negative times negative is positive 6i squared. Remember, I squared is negative 1. So 6 times negative 1 is negative 6. If I put all that together, what do I get? 14 minus 6 is 8. And then negative 21i and negative 4i is negative 25i. So that's what I get on top of this fraction. The top of this fraction is 8 minus 25i. 8 minus 25i. On the bottom of the fraction, I need to do 2 plus 3i times 2 minus 3i. And we hope all of the i's go away. That's our goal. So let's do that. 2 plus 3i times 2 minus 3i. 2 plus 3i, 2 minus 3i. 2 times 2 is 4. Negative 3i times 2 is negative 6i. 2 times 3i is positive 6i. 3i times negative 3i, that's negative 9i squared. That's negative 9 times negative 1. That is positive 9. So if I add all this together, I get 4 minus 6i plus 6i plus 9. You'll notice the i's do go away, and all I'm left with is 13. That is the denominator. So that's not quite standard form. For a complex number, standard form is a plus bi. So we'll write that as 8/13. I'm going to say minus. You could say plus negative, but minus 25/13 I. I think that's close enough to complex number form for us. So that's what we would get if we would divide those two complex numbers. Let's go ahead and do one more of those. We'll go ahead and divide two more complex numbers. So let's take a look at the following. 6 minus 2i divided by 4 plus I. So to do this, we're going to multiply top and bottom by the conjugate of the denominator. Equals 6 minus 2i over 4 plus I times conjugate of the denominator 4 minus I downstairs, 4 minus I upstairs. So you've got to multiply the tops, 6 minus 2i times 4 minus I. I like my multiplication box, so let's use it. 6 minus 2i times 4 minus I. 6 times 4 is 24. 6 times negative I is negative 6i. Negative 2i times 4 is negative 8i. But negative 2i times negative 1i, negative times negative is positive 2i squared. That's 2 times negative 1, that's negative 2. So if we put all this together, what do we get? 24 minus 2, 22. Negative 6i and negative 8i is minus 14i. So 22 minus 14i is what we will get in the numerator. And then we need to go ahead and do 4 plus I times 4 minus I, and we hope all of the i's go away. The point is to rationalize the denominator. So let's do that. 4 plus I times 4 minus I. 4 plus I times 4 minus I. 4 times 4 is 16. Negative I times 4, negative 4I. Positive 4 times I. Positive 4I. Negative I times positive I is negative I squared. That's the negative of negative 1, which is positive 1. So when all this is settled, what do we have? 16 plus 4i minus 4i plus 1. So this result is just 17. So 17 is downstairs. We want to put this in a plus bi form or a minus bi form. So that would be 22/17 minus 14/17 I. And that will conclude this lesson.